Hey, hello, welcome to Science Share course. In this video, we're going to see about the chemistry of water. So what is this chemistry of water all about? So we know that chemistry is nothing but the structure, composition and properties of matter. So yes, we're going to deal about the structure of water molecule in this particular video. Yes, now what is the chemical formula for water? We know that the chemical formula for water is H2O, where two hydrogen atoms have been combined with the oxygen atom. Fine. Now, what kind of molecule is this? Fine. What kind of molecule is this? This H2O is a polar molecule. Fine. So, now first let us understand what is a polar molecule. Why this water is considered as a polar molecule. Now, this polar molecule is nothing but when a chemical compound, right, when a chemical compound is formed and the distribution of the electrons between the covalently bonded atoms, we call it as a polar molecule. Fine. Now, I'll just, in a short form, I'll just write it as the distribution of electrons is not even. Okay, so maybe to understand this polar molecule, we need to know what is a covalent bond, how this bond has been formed between this oxygen and hydrogen. All those things, if we understand, this becomes very easy, right? Now, first let us take the structure. So there are two hydrogen atoms and we are having one oxygen atom, right? And we know, right, this is a molecule. So how a molecule will be formed? Two or more atoms should combine together chemically. So how they are combining? There should be some interaction between the atoms. What is that interaction called as? It is a chemical bond. So there is a bond between the oxygen and as well as the hydrogen, right? So there are two hydrogen atoms and one oxygen atom. They are combined with a chemical bond. Now, how this chemical bond has been formed, that we need to know. So in this case, this bond which has been formed between the oxygen and hydrogen is called as a covalent bond, right? So what is this covalent bond? Covalent bond is nothing but a bond which has been formed due to the sharing of electrons between the atoms. So this covalent bond is nothing but sharing of electrons. So a bond formed because of the sharing of electrons between the oxygen and hydrogen is called as covalent bond. So what kind of sharing has happened, so that we are calling it as a polar molecule. So to understand that, now let us see the number of electrons present in oxygen and as well as hydrogen. So first let us take oxygen and the next one will be hydrogen. Fine. So how many electrons are there in the outermost shell of the oxygen? It is totally 6 electrons, right? In the outermost shell it is 6 electrons. What we call it as? It is the valence electrons. And in case of hydrogen, there is only 1 electron. So oxygen needs 2 more electrons for stability and hydrogen needs another 1 more electron for stability, right? So oxygen needs 2 and hydrogen needs only 1. So what is happening? This oxygen is having 6 electrons in it and it needs 2 more electrons. So what it does, it is sharing with the hydrogen which is having 1 electron with it. Okay, so this hydrogen is having 1 electron and our oxygen needs 2 more electron, right? So in this case also there is 1 electron. So oxygen needs 2 more electrons which is being shared between the hydrogen. Like what is happening? This oxygen is sharing 1 electron from this hydrogen and another electron from another hydrogen, so that it gains 2 electrons and it gains the stability. Fine. In this case also, when you take hydrogen, how many electrons it needs? It needs 1 electron. So what it is doing? It is sharing the electron from oxygen. So this hydrogen is sharing this electron and this hydrogen is sharing this electron. So that hydrogen's stability also is gained. Fine. Now, what has happened in this case is the electrons does not lie in this place or it is in the center, right? So I'll just tell you. Now let us take this. Fine. Yeah. Right. So this is the electron of oxygen and this is the electron of hydrogen. Right. Now these two electrons are going to be shared. Right. Now it is not in the center. Okay. It is not in the center or it is not towards the hydrogen. Okay. These two electrons are towards the oxygen. Okay. This is towards the oxygen. Right. Why is it so? This is because oxygen is more electronegative. What is meant by more electronegative? It's nothing but the ability of an atom to attract the electrons towards itself. Okay, but still there will be a sharing of electron, but what happens is that this electron will be towards the oxygen. The electrons will be towards the oxygen, but still this hydrogen is not giving away the electron to the oxygen. It's not just giving away the electron to the oxygen. It is still the electron of hydrogen, still it is sharing, but the electrons will be towards the oxygen because oxygen is a more electronegative atom. It can attract the electrons towards itself. Okay. Now we know that these two electrons are towards the oxygen and it is not a equal sharing if you see, right? Is there any equal sharing here? The electrons are towards oxygen atom. It is not an equal sharing. So there is a distribution of electron which is not even. That sharing is not equal, right? So that is why we call this molecule as a polar molecule. Fine. And because of this unequal sharing of electrons, there forms a charge on hydrogen and as well as oxygen. What kind of charge? In this case, there is a partial positive charge on the hydrogen, and in case of oxygen, there forms a partial negative charge. Why it is partial? Why not totally plus negative and why not totally positive? This is because this hydrogen has not totally given the electron to the oxygen. Still it is sharing. Still this electron is hydrogen's electron and this electron is hydrogen's electron. But since the electrons are towards the oxygen, right? The electrons are towards the oxygen, there occurs a partial negative charge and in this case there is a partial positive charge. Fine. So this makes water molecule a polar molecule. So now, what kind of interaction is there between one H2O molecule and another H2O molecule? Let us see. So now this is one and this is another one. So there is a hydrogen atom here and there is a oxygen atom here. And we know that it is a partial positive charge and in this case it is a partial negative charge. Right? So we know that they are the opposite charges which gets attracted towards itself. So what is happening? There forms an interaction, or you can call it as a force of attraction between hydrogen and the oxygen of another molecule. Okay, so this interaction is called as hydrogen bonding. So this interaction is called as hydrogen bonding. So by definition it is nothing but a strong intermolecular force. Okay, a strong intermolecular force when it is occurred between hydrogen and a more electronegative atom. Okay, so a bond, it's not a sharing of electron which has taken place here. It is just a force of attraction between hydrogen and a more electronegative atom. It is not always oxygen, it can be anything. In this case, since it is another H2O molecule, O is, that is oxygen, is more electronegative. So this interaction or a force of attraction between hydrogen and a more electronegative atom, we call it as hydrogen bonding. So between one H2O molecule, it is covalent bond, and if you're taking another H2O molecule, the interaction will be an hydrogen bonding. So now this hydrogen bonding is there, right? Now what is happening? This, now if you are having another H2O molecule here, so what will happen? There will be again an hydrogen bonding with the oxygen atom, right? Again, likewise it goes on. So in this case it is hydrogen bonding. Yeah. Now let us see the this V-shaped structure of water molecule. Why not why not this is a linear molecule? Why not in this way? Or why not in some other different shape? Why this water molecule is in this shape? So to understand that, now first let us see the lone pair of electrons which are present on the oxygen. Okay, what is this lone pair of electron? It is nothing but the electrons which are not taking part in the bond formation. So now in this case, only these two electrons has been shared between the hydrogen atoms. These 4 electrons are not shared with any other atoms. So these atoms are considered as lone pair. So this is one lone pair and this is one lone pair. So totally 4 electrons are there, right? Now what is happening in this case is the bond angle of water, okay, the bond angle of water is around 104.5 degree. The reason this hydrogen, the reason these bonds have been bent in the sense, like what happened was, we know that the bonding electrons are towards oxygen, and oxygen is having the lone pair of electrons on it. So we know that electrons and electrons repel each other since they have the same charge on it, like negative and as well as negative. So what happened in this case is, now for example, if you take oxygen and it has 2 lone pair of electrons in it, and if you take the hydrogen, and we know that the electrons are towards oxygen. So what has happened is, in this case, repulsion of electrons is happening. Repulsion of the lone pair of electrons and the bonding electron which is there in between the hydrogen and oxygen. So because of the repulsion of the lone pair and the bonding electrons, this bond has been bent in this way, and you are getting the bond angle as 104.5 degree. Okay, that is the reason wherever you see the water molecules are in this shape, or you can either it is in this shape or it is in B shape, right? This is the reason why it is in this particular shape, and the bond angle is around 104.5 degree. So this is all about the structure of the water molecule. So in the upcoming videos we are going to see about the different properties of the water. Fine, thank you.